Math with Mr. Williams, example 1. Making a box and whisker plot. Make a box and whisker plot for the ages and years of the spider monkeys at the zoo. So here we have all the different ages, and we're going to go ahead and put those in order. So our first number would be 14. Then we have 15, 20, 26, 27, 30, another 30, another 30, 33, 35, 36, and 38. All right, so right off the bat, we can find our greatest value. We can find our least value. And now we can find our median. So the median is the number in the middle. So since we put them in order, all we have to do is find the one in the middle. So between these two 30s would represent the median. 30 plus 30 divided by 2 is still 30. All right, so now let's take a look at the first quartile, which is this set here. All right, and that middle number will be between 20 and 26. So if we add up 20 plus 26, we would get 46. Divide that by 2, and we end up with 23. So our first quartile, Q1, is 23. Now our next one would be between 30 and 35. So we add these two up, divide by 2, and we would get 34 for quartile 3. All right, now let's go ahead and draw a number line that includes the least and greatest values. Now, since the numbers are all over the place and we don't want to have a lot of space, what I'm going to do is I'm going to go by 2's. Okay, now we have a number line. Now I'm going to go ahead and place our 5-number summary. Basically our least value, our greatest value, our median, the quartile 1, and quartile 3 numbers. So the first one is the least value. All right, and that's at 14. So our next one will be at 38 for our greatest value. Okay, and now we're going to go ahead and put a dot where 30 is for our median. And now we're going to put a dot where our quartile 1 is, our 23, and then finally our quartile 3 at 34. After we've graphed our points above the number line that represent the 5-number summary, we're going to draw a box using those quartiles. All right, and now we're going to draw a line through our median, and we're going to draw our whiskers from the box to the least and greatest value. And lo and behold, we have our box whisker plot. Math with Mr. Williams, example 2, analyzing a box and whisker plot. The box and whisker plot shows the body mass index, the BMI, of a ninth grade class. First question says, what fraction of the students have a BMI of at least 22? Well, there's a key word there is least. So let's go ahead and look at the box and whisker. We know that this represents 1/4 of the data. This side of the box represents 1/4, 1/4, and then this big section up here represents the other quarter of the data. We see that the box itself represents half the data in the middle. All right, so let's answer the first question. It says, what fraction of the students have a BMI of at least 22? Well, at least means the minimum. So we're down here at 22 here. And so that means if all these numbers up here, so what fraction of those students? Well, 1/4 of the students have at least 22. Are the data more spread out below the first quartile or above the third quartile? Well, here's Q1 right here, and here's Q3. So is the numbers more spread out below it, which looks like 2 spaces, or above it, which looks like a lot more than 2? We have 1, 2, 3, 4, 5, 6 spaces. Well, it looks like the data is more spread out above the third quartile. C, find and interpret the interquartile range of the data. Well, all that means is we take Q3 and we subtract Q1. So the Q3 number was 22 minus Q1 was 19, and that gets us 3. So the middle half of the student's BMIs varies by no more than 3. Math with Mr. Williams, example 3, identifying shapes of distributions. The double box and whisker plot represents the lifespans of crocodiles and alligators at the zoo. Identify the shape of distribution of the lifespans of the alligators. So if you remember, our shapes of distribution are skewed left, where the numbers are skewed or stretched out on the left-hand side of our box whisker plot. We have symmetric, where they have equal distributions on either side of the box. And then we have skewed right, where there's a big space on the numbers. We can see that whisker is really pulled out on the right-hand side. So for the alligator lifespans, the whisker lengths are equal. The median is in the middle of the box. The left side of the box and whisker plot is a mirror image of the right side of the box and whisker plot. So the distribution is symmetric. Math with Mr. Williams. Example 4, interpreting a box and whisker plot. The box and whisker plot represents the lengths and seconds of the songs played by a rock band at a concert. Okay, so question A says, find and interpret the range of the data. Okay, so to find the range of the data, we take the greatest value and we subtract the least value. So we have 300 minus 160 will give us 140 for our range. This means that the song lengths vary by no more than 140 seconds. B, describe the distribution of the data. Okay, well we see that between 160 and 220, this represents 25% or 1/4 of the data. The box itself represents 50% of the data. And then up here at the very top, we have another quarter or 25% of the data. We can see that the data is skewed left. We can see that long whisker on the left-hand side. We see that it is much more between 160 to 220 versus 280 to 300. Therefore, there's more numbers that are spread out in that whisker. C, find and interpret the interquartile range of the data. So we take Q3 minus Q1, meaning we take 280, and we subtract 220, giving us 60 for our interquartile range. So the interquartile range is 60 seconds. This means that the middle half of the song's lengths vary by no more than 60 seconds. D, are the data more spread out below Q1 or above Q3? Well, this goes back to being skewed left or skewed right. Well, it's definitely more skewed for Q1. So the data below Q1 are more spread out than the data above Q3. Math with Mr. Williams. Example 5, comparing box and whisker plots. The double box whisker plot represents the test scores for your class and your friend's class. It says identify the shape of each distribution. Okay, so for your class, the left whisker is longer than the right whisker, and showing that most of the data is going to be on the right side of the plot. So the distribution for your class is skewed left. Now your friend's class, the whisker lengths are equal, and the median is in the middle of the plot. So the distribution for your friend's class is symmetric. B, which class's test scores are more spread out? Okay, well that deals with more with the range and the interquartile range. So let's go ahead and find them both. So for your class, we have the range. It's going to be our greatest number, which would be 100, minus our least value, which is 70, giving us 30 for our range. All right, and our IQR, interquartile range, would be what's inside the box. So we have 95 to 85. We subtract our Q3 minus Q1, giving us 10. So your class, the range is 30 and the IQR is 10. All right, so let's go take a look at the friend's class. So the range, we would have 100 minus 60, giving us 40. And the IQR being 90 minus 70, which give us 20. The range and interquartile range of the test scores for your friend's class are greater than the range and interquartile range of your class. So the test scores for your friend's class are more spread out.